Your English teacher asked you to select 3 novels from a list of 10 to read as an independent project. In how many ways can you choose which book to read? Choose 3. What'd you get?
10, yeah, 10 choose.
Yeah. I gotta get some crazy blue. Anybody got any crazy blue?
No.
What?
You have to be 18 plus
You crazy meth heads.
Do you really have to be 18 years old?
Yeah.
Yeah, you know what? That reminds me. You're right, because I got carded once to buy. I think it was spray. It wasn't spray paint. It was some. Yeah, it was a canned air. You're right, because I had to get it for our computers at home, which was all messed up.
What?
What's that? Well, never mind. Your friend is having a party and has 15 games to choose from. There's enough time to play 4. In how many ways can you choose which game to play?
The answer is always
What?
Wait, are you?
Yeah, I'm on 48. 15, choose 4. I'm going out on a limb that these probably aren't that terrible.
50's not that bad.
I want to check it.
Some of them seem like a bigger number though. But
Yeah.
like 53.
Well, when you start thinking about what 15 choose 4 is,
It's literally.
that's 15 factorial, 11 factorial, 4 factorial. So the 11 factorial was gonna cancel out anything below 11 and down here. So it's just 15, 14, 13, and 12. And this is 4, 3, 2, and 1. Well, 4 and 3 is 12. 2 goes in here, 7. So it's only 15, 7, and 13, really. That's why the numbers aren't as big as what you think they would be. Is that when you break it down this way, you start to realize that these aren't really giant numbers. You're buying a new car, hooray! There are 7 colors to choose from and 10 different optional equipment you can buy. You can choose 1 color and can only afford 2 of the options.
Is the answer 14?
Why do you say 14?
Wait, hold up. There's only 7 colors.
Uh-huh.
You can only afford 2 of the options.
Okay.
What would you use on
2 of the 10 options.
But it's out of the 10. How many different ones you can pick?
But I thought you can only afford 2 of the 10, so you really have only 2 to choose from.
But you have 2 to choose from out of the 10. What combinations can you pick out of the 10?
Oh,
See what I'm saying? Does that make sense?
no.
Okay. It's not that you have, what you're thinking is there are 7 options for colors and 10 options for packages. That would be 7 times 10, which is 70. Here you're picking 1 color, so 7 choose 1, that's just 1.
Yeah.
Or sorry, there's 7 different ones that you can pick from. And then you have 10 options, you can pick 2 of them. So you 10 pick or choose 2 is what it winds up being.
Oh,
And it's compounding because there's because of the word and. So you have a 7 choose 1 times 10 choose 2. Yes, ma'am.
Wouldn't you times that by 10 choose 1 because you have the option of only choosing 1 options?
That's when you,
Choose 2.
yes, because it's saying you are choosing 2. It would say something differently. You can choose at most 2 options. And when you have the at most, that's when you're going to start seeing the addition stuff. All right. So here you'll have 7 factorial over 6 factorial, 1 factorial. So this is 7 times. And then again, if you write it out long form for the 10 factorial, and then it would be 8 factorial, 2 factorial. So this is just 10 times 9 over 2, which is 45. So it's really fast to do it shorthand. There are 6 artists presenting 5 works of art in an art contest. Yo!
It's, we take 45 times 7. It's essential. Oh. You just really
I just did the first, I just did that. You feel that? There are 6 artists, each presenting 5 works of art in an art contest. 4 works judged best will be displayed in the local gallery. How many ways can these 4 works be chosen from the same artist's collection? This is kind of like along the lines of the card trick stuff that we were picking out. First, you have to select an artist. You agree on that? So you have to select your artist. 6, choose 1, and then you have to multiply that by how many pieces of art does each artist have, and how many of them do you want? I think it was 5, 4, right? It would be that. Pick the artist, and then all of their artwork. Look back at example 2. Suppose you can afford at most 7 ingredients. How many different omelets can you order? That was the one where we were talking about bacon and it was ham, bacon, and cheese and all that kind of junk. There was what, total of 10 options, I believe? So that one was the food one. I think I still have. Let's pull that up. There it is. It sounds like that. So you can afford at most 7 of them. Well, how many of them do you have to find then? Can you choose nothing? Just get eggs?
Yeah.
And you just add all those up. Yes.
Is there like a shorter way to write that, or do you?
You could, if I'm not mistaken, I think the other way to go through it is with subtraction. Do like the not get them. But then you have to figure out the total possible and then subtract out getting. And a lot of times when you start getting into the subtraction ones, you're right, it could work elevated. It's going to be easier when we deal with probabilities later, because a probability of an event occurring is favorable over not, whereas if you know what's called a complement, it's just 1 minus the probability of it happening. For example, the probability of rolling a 6-sided die and getting a 3 is 1 out of 6. Do you agree? What's the probability of not getting a 6? 5 out of 6, or 3, excuse me. You take the probability of it happening and then the complement of it, which is the opposite. You guys okay? Did you guys have a good weekend? When's skate? Sweet. Awesome. Where do they have state for that? That's Chestnut. It starts with a C. What's the name of the town? Is it? What is it?
Wait, what?
Eastern?
Charleston.
Charleston. Thank you. Is that?
Like the Charleston Chew.
When's the last time you saw a Charleston chew?
They used to have them at Hopkins.
Really?
It used to have
Yeah,
that.
like big football.
Oh, I know he's the strawberries. Oh.
You see them all the time.
And they got some for Halloween this year.
Yeah.
Amusement parks.
I was never a big.
You have their amusement park has 20 rides. You want to go on at least 15 of them. But you want to go on at least 15 of them. Yeah. So you gotta do, yeah.
Wait, do you gotta do 15?
Yeah, that's fine. That's fine.
I skipped that.
And let's see, then we left off the last couple. Fish! An aquarium enthusiast is interested in knowing how compatible any group of 3 or more different species are. Fish. An aquarium enthusiast is interested in knowing how compatible any group of 3 or more different species are. How many different combinations are there to consider?
So we're just gonna put a bunch of fish in one time and see if they kill each other?
Yes. It's gonna be a fish brawl.
Angel fish is gonna die.
Doubt it.
Doubt it.
So-
It's got heart.
No. The shark is
Trust
going to
me.
win.
Trust me.
The
So,
shark is obviously going to win.
I'm pretty sure there's.
It said the tiger part, part of the bottom.
Right, neon.
do I need to go through that one, or are we okay?
I'm going with the cat.
Go through it? How many fish do you want?
So would it just be 10 to 3
Yep. How many different ways can you put them all together?
Wait, if we just do 10 to 3 10 twos, 4, and put that like that, 10 to
And just do it on your calculator?
3.
Yeah, it's fine. You don't have to write it all out.
That's what I was asking.
Oh, I'm sorry. I thought you were thinking of like a shortcut method to solve the answer. Yeah, no. When you get to something like that where you have it on 53, where you're doing 10 choose 3, 10 plus 10 choose 4, all the way up to 10 choose 10. If you write it like that, that's fine. Yeah, that's what you're saying?
Yeah, that's it.
Yeah, absolutely. Because you're going to do the work in your calculator anyway.
Okay, I like wrote it.
You like that?
Yes, sir. Yes, sir. Yep. What else do we have to do? 54. So 54 is one that we could probably. The summer concert series has 12 different performing artists. You decide to attend at least 4 of them. How many different combinations can you go to? Well, if you're gonna go to all. This is again, you're either gonna go or not go to a concert. Do you agree? And if there's 12 of them, this might be as close to a shortcut that I can show you, aside from doing 12C4 all the way up to 12C12 in this case.
It's adding them all.
Correct. Yeah, this is adding them all.
Nice.
If you're gonna go to a concert, what's your 2 options of going to a concert?
To go or not to go?
Go or not go?
That is the question.
How many times would you have to ask yourself that for 12 concerts?
12 times.
12 times. So you basically have go, no go, like this. That's your total go, no go. You agree?
Let's see.
Because you have 2 options 12.
So
12
you
times.
take into account if you don't go to any concerts, you don't want to go at all?
Well, the question here is, do you want to go to at least 12 of them?
What
Or,
kind
I'm
of
sorry,
music is
4
there?
of them. So you would be going 12C4, 12C5, all the way up to 12C12.
Oh, so it's at least 4 of them.
Yeah.
So you go more.
Correct.
Okay, I got it.
So,
I was wondering why you go up.
and that's where I'm going. This is kind of about, this is the, I mean, you'd have to do a lot of addition once here. I mean, granted, guys, it's just calculator work. It's not that terrible. But in this case, there is a somewhat decent shortcut-ish, because you're either going to go or not go. And you have to ask that question 12 times. So that's why it's 2 to the 12th power for go, no go. That's your total possible yes or no type things for the concerts then. Now, if you take that into consideration and subtract out not this, 12C0, 12C1, 12C2, 12C3, it's just a little bit less work.
It's the same.
It's the same thing. You're going to get the same answer. This is kind of like using the complement idea. You know, probability of rolling to 3 is 1 out of 6. The probability of not rolling to 3 is 5 out of 6. You're going back, you're using the opposite, but I'm taking it from the total possibles. That's all it is. Either way, it's going to be fine. If you don't want to do it this way, it's fine. It's just a little less work than having to type it all out. That makes sense. That's all. And then, was that all we had to do? Okay. As much as I really, 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 really want to get into this stuff today,
No, thank you.
it's not that it's I need more time than 15 minutes to walk through this, because this gets a little gnarly.
That's the first time I looked at it.
You guys ever heard of Pascal's triangle?
Yeah.
Sounds familiar.
No,
Is
I
that it?
haven't.
Pascal's, yes.
Somebody's gonna shoot
Kind of like a
Pascal.
generalized thing.
Pastel.
If it's like 3 choose 1,
Art
it's
term?
3.
Yeah.
So if it's like 1 choose 1, then you
What happens here is that there's a number pattern that occurs if you start with 1, 1, 1. If you bring ones all the way down the outer edges of a triangle, you can rewrite the numbers in between them as the sum of the two above it. 1 and 2 is 3, 2 and 1 is 3, 1 and 3 is 4, 3 and 3 is 6, 3 and 1 is 4. 1 and 4 is 5, 4 and 6 is 10, 6 and 4 is 5, 4 and 1 is 5, and I bring it
Say
up.
6 and 4 was 5.
No,
I was like,
5. It's not even subtraction.
and this continues infinitely down. But the reason that this is important is because of this. Junk squared is what?
jump,
Times
jump.
junk. So if I FOIL that out, I get x squared plus xy plus xy plus y squared, which is x squared plus 2xy plus y squared. Okay. What about x plus y cubed?
Jump. Times jump.
Times junk. So
Times jump.
basically, I'd have to multiply this again by an x plus y. You agree on that?
See,
So watch what happens. You get x cubed plus 2x squared y plus xy squared plus x squared y plus 2xy squared plus y cubed. I'm just foiling out, so I get x cubed, it's gone, plus 3x squared y plus 3xy squared plus y cubed. Doesn't that look at the coefficients?
what?
1, 3, 3, 1.
Where's the time?
1, 3, 3, 1. Look at the coefficients.
Who takes time out of their life to figure this out?
Pascal?
Well, someone needs to punish Pascal.
But why?
Well, he's
Like-
already dead,
Like,
so.
why did you figure this out?
Why? Why would anyone
Was he
want
just
to
like,
figure this out?
it works, so let's just do
Hey,
it.
hey, let's see like making this into a triangle.
Yeah, let's do.
Let's
What-
do a triangle. It was probably a bet. They're like, hey, I bet you can't make this into a triangle. He's like, yes, I can.
What happens is this is going to allow us to take a polynomial
Whoa.
and not have to FOIL it out to the 12th power.
You could have taught us this.
Oh, so after one,
So
down
now we
like
can
12
choose-
times, is that what you're saying?
Now we have to go 12.
So if you go 1 and then 11 more ones.
Well, we have to figure out what we would have to do. Now, if you start looking at the pattern of these things, this all follows into the same thing of, well, it's, what does it be? 1 choose 1, or excuse me, 1 choose 0, 1 choose 1, 1 choose 0, 1 choose 1, 2 choose 1, 3 choose 1. And it just starts going through like that. And you start looking at these. It falls into the pattern of all the combinations dependent upon degree. If you have a third degree, it's 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3. Those are going to be leading term coefficients of binomials as we expand them. So if I have something that's to the 12th power, I'm going to start with 12C0, 12C1, 12C2, and so on and so forth for all the coefficients for my terms. Now think about 12th degree polynomial. it can have 12 zeros, obviously. How many terms will it have going through it? What I mean by terms is pieces. Do you remember how that worked?
Nope.
How many terms does a junk squared have when you FOIL it out?
4.
3. How many terms did a cubic have?
4.
4.
Whoa,
It'll be 13 terms. There's always n plus 1 terms when you FOIL something out. So there would be 13 terms here. What's the highest degree it's going to have? So the 12. And each term successively would go down 1 degree. But what about the other stuff? What about this term was started at 12 and go all the way down to nothing? What would the y term wind up at? If you go back and look at what we had here, x cubed, x squared, x, no x, no y, y, y squared, y cubed. It goes reverse.
I thought you said we weren't going to do more of this.
Let's start to share a little bit. So what's going to happen here is that you're going to get these terms. Well, the first term be the 12. Next one be 11 with 1 y. 10,
Oh, I see that.
2 y's, 3 y. And notice what all these exponents always adding up to equal. 12.
Now I see.
One's descending while the other is ascending.
Yeah, that's not too bad. I can figure out that pattern.
Oh, I went the wrong way. So this is 5,
Oh, no.
6.
Never mind.
Anyway, but what'll happen is, as we get into more of this tomorrow, I'm going to ask you, what is the 8th term in that?
2x. Which one?
Nope. 4. Nope.
I thought I had it.
Because each one of these values, this whole piece is squared, cubed, and so on. Because that's the part in the polynomial. Because if you FOILed out 2x minus 3y, just fold it out, with this quantity squared, you'd get 4x squared and go from there. So there's a lot of little things that are going to happen here, and that's why I was saying, you're right, the initial pattern, you can figure that out. That's not too bad. Power's going down, power's going up, power's sitting down. That's good.
I'm so
But the goofiness gets into be with the actual exponents and how we do this. We do a lot of what's called, remember how I showed you guys before that U substitution?
Yeah.
We do a little bit of that here as well. And we just finished this out in pre-calc yesterday or a couple days ago as well. And it's pretty neat how these things work. It's a real nice shortcut how it goes. I'm not going to go any further than that. I just wanted to give you guys a little heads up on where we're leading.
Mr. Murphy, I lost on the movie.
Told you, you got to quit gambling, man.
Good.
$4.5 million.
How much did you lose?
Still not winning.
$4.5 million.
You bet it all.
Was it worth it?
I went all in.
That's right.
Yeah,
If it's virtual money,
And the
it's
guy had a
all
royal flush. I had a straight flush, and the guy had a royal flush. I thought I was good.
You lost the royal flush?
I lost.
Then you know what? Then it's legit.
Yes.
So Kobe, are you done playing it then?
Yes, I deleted the game. I got really mad at it, but I didn't play the game.
Maybe in a week or so? Maybe end of this week? End of next week?
So if you would burgers and oh,
Here, let's do both sides, but don't do 9 through 14 on either side.
Don't do 9? Okay.
Yeah, because you don't know how to do it yet.
Thank you.
Wait, exit out. 9. What if there's 15, 16, 17, three of those ones too?
Should I cross line through 9 or 14?
Okay, awesome.
Yeah, 9 through 14 on both. Yeah, that works both sides. All right? Because we haven't done the binomial. That's the whole expansion that we're going to get into tomorrow. Okay?
No, you can't pick each other.
Hey, Mr. Murphy, what was you were doing with that stuff up there?
Geometric probability. At least you've seen it.
Oh, yeah.
Counting squares, that's hard.
I'll show you.
Yes.